So it was in 2019 while I was finishing my master in law, and I was attending in parallel multiple courses at EPFL as an auditor. And one of them was entitled Advanced Privacy Enhancing Technology, and it was given by Jean-Philippe Bossuat, the head of a laboratory for data security, and Carmela Troncoso, the head of a security and privacy engineering laboratory at EPFL. So there was actually an entire chapter dedicated to lattice-based homomorphic encryption. And at the time, I was very glad that to have an entire chapter dedicated to this topic because my semester project happened to be to prototype a full RNS implementation of the BAV scheme. So it helped me understand the basic of lattice-based cryptography and get the appropriate references. So for me, this is a tricky question because if you look closely on how these each schemes works, which I had to do to implement them, you start to understand that they are not so different after all. So I think once you realize that RWE-based encryption has only three well-defined operations, which are addition, multiplication, and automorphism, and that everything else is based on these three basic operations, you see that these schemes are not so different after all. In fact, the only difference is between what we call schemes is how plaintexts are encoded and how operation might be adapted to accommodate for this plaintext encoding. And this is also why it is possible to homomorphically switch between the schemes, because what is actually done is just homomorphically switch between different encodings. So the semester project I mentioned earlier was to prototype a full RNS implementation of the BV scheme, and it produced very good results. And as such, I was offered to continue to work on it and expand the library to other schemes as a researcher in software engineering at the Laboratory for Data Security at EPFL. I had a very good experience working with a team during my semester project, so I was very happy to accept their offer and continue to work with them. And this was actually the birth of the Lattigo library. And 4 years later, I'm very glad that it has become one of the most established library in the field of lattice-based homomorphic encryption. So I was a law scholar, so I was lacking the entire mathematical background, the coding and software engineering skills when I started this master project. The only experience I had was an introduction to cryptography, and I had coded in Python a little bit before, but what was it? And getting used to reading academic papers took a while too, because I was really not used to have to read like really long convoluted equation with a lot of symbols. It was really like giving headaches. It's like learning a new language. But luckily, I had a very good support from the LDS team on both the theoretical and the software engineering part, so they helped me a lot on that. I would say that what helped me the most in the end was to be able to concretize the theoretical side of FHE into actual code and watch it work and play with it. And when the code was working, I knew that I had at least understood the theory behind it and that it was implemented correctly. Interestingly, this enabled me to have a different approach that wasn't purely theoretic, but also algorithmic. And in some cases, it allowed me to find like simpler representation of operations that were proposed in the literature. So at the moment, the industry is still at its very beginning and probably will in the foreseeable future. We are starting, however, to see commercial applications that are in, because their FHE enables collaboration that weren't previously possible, but it's still between businesses. I think it will really take off when PETs as a whole will start to be standardized, and which will allow lawmakers to make them mandatory for at least a subset of applications. I think public perception and education. It would be great if it was if there was an easy way to understand for someone that wants to use it or is offered a product that uses it to understand what it is good at, what it enables, what its cost, and what it is bad at. Because right now you still need to be an expert to be able to assess this. And the entry barrier could also get some love. It is difficult for newcomers to know where to start. And and what is the required knowledge, and get a good idea of what is the current state of the art. So I have two advice. The first one, I know is the generic one, but life showed me that it actually matters a lot. It's to meet and to work with people who can either or both improve your knowledge and expertise or need your knowledge and expertise. In my case, it was to work in the LES laboratory and being surrounded by people that were really good at what they did, be it like software engineering or the theoretical part of FHE. This really helped me to bring my knowledge up. And the second advice is to be multidisciplinary. So by itself, FHE is a technology at the frontier of what I think three fields: abstract mathematics, applied cryptography, and software engineering. And my experience taught me that it's better to be good enough at the three than to be an expert in one and neglect the two others. And often this is not even enough because FHE is used into applications that need specific knowledge, for example, machine learning or statistics. And to be able to apply FHE correctly, you also need to understand this where in the context where it is used, be it technical or legal.